Hello everyone, my name is Rahul Kurula and today I am going to take class on electromagnetic induction. So this electromagnetic induction, it is a very easy topic because if you understand the concept, then it is easy for us to understand its applications, because there are a lot of applications which are related with the electromagnetic induction. So it is very necessary that we need to understand the concept. So if you understand the concept of this particular topic, then it is very easy for you to go with the applications. So now we'll go with the class. Here we can see a coil. Okay, this coil can be anything. It is like a inductor coil. Okay, so this inductor coil is connected to a galvanometer. Okay, so what is a galvanometer? The purpose of galvanometer, it is actually used to identify the or to sense the current. Okay, so here we can see there is a coil. This coil is a inductor coil, and this inductor coil is connected to a galvanometer. Okay, and this galvanometer is used to sense the current. Okay, now here we can see near to this particular coil, we can see that there is a magnet. Okay, this is a bar magnet which has a north pole and south pole, and as you all know that the direction of the magnetic field in a bar magnet is always from a north to south. That we have already learned in the earlier classes. So here we have bar magnet which has north pole and south pole, and the magnetic field direction is always from north to south. Okay, so now what happens is that here initially we move this bar magnet, that is from right side to left side. Okay, that is from right side to left side we move the bar magnet. So what happens? Naturally the field lines, the magnetic field lines of the bar magnet will get linked with the coil. Okay, now second step, what we do is that we move the bar magnet from left side to right side. Okay, now what happens? The magnetic field lines which is linked by the bar magnet with the coil will be reduced. So I repeat, initially what we do is that we move the bar magnet from right side to left side. So what happens? The magnetic field lines which is linked with the coil will be more. Now in the second step, what we do is that we move the bar magnet from left side to right side. So now what happens? The magnetic field lines which is linked by the coil, or magnetic field line which is linked by the coil will be reduced. That is because the magnet is moving away from the coil, right? Initially it was coming close to the coil, now it is moving away from the coil. So naturally the field lines which is linked with the coil will be changing. Okay, so now what happens? Since the magnetic field lines is getting changed each time with the coil, so that time it produces a EMF. Okay, so this EMF is nothing, it is just a potential difference, voltage or a potential difference, we say it is a voltage difference. Okay, and as you all know that because of this EMF or because of this potential difference only the current flows. So what happens when there is a change in the magnetic field lines which is linked with the coil, that time a EMF is developed. This EMF is nothing, the potential difference, and due to this potential difference a current is developed, and this current is sensed by this galvanometer. Okay, so the concept itself of the electromagnetic induction is that when a magnet moves from right side to left side, the magnetic field lines which is linked to the coil will be more, and during the second step when the magnet is moved from left to right, the magnetic field lines which is linked to the coil will be reduced. So this change which is happening in the magnetic field lines with the coil will create a EMF, that is a potential difference, and because of this potential difference a current will be developed, and this current will be sensed by the galvanometer. So this is the whole concept of the electromagnetic induction. Okay, so the application of electromagnetic induction is one is the generator. Okay, so this is I just explaining. Okay, Here we can see there is a, this is the armature coil. Okay, so what happens is that here we can see there is two magnets, north pole and south pole, two magnets are there, and in between we keep an armature coil. Okay, so same thing happening here. As you know, the magnetic field lines is moving like this, right, from north to south. So in between there is an armature coil kept. So as we already have learned in the earlier classes that when the in a generator, what happens is that the mechanical motion is given, and with this mechanical motion only the electricity is produced. Okay, so here we provide an external mechanical motion, and because of this external mechanical motion, what happens, the armature coil which is linked with the magnetic field also get changed. That is, we provide an external rotation, that is external mechanical rotation. So with this mechanical rotation, the armature coil which is linked with the magnetic field will get changed. So this change in the magnetic field when with respect to the coil, that is the armature coil, will produce an EMF, and with this EMF a current is produced. So this is the just one application which I am giving with respect to the electromagnetic induction. Okay, so we'll study in deep of the generator in the next class. So I hope everyone has understood the topic. So thank you.